Greetings, teachers. This lesson is called Inflate the Balloon. And in this lesson, students will be observing a phenomena to collect data that will help them construct explanations later through their evidence of what they observe. Before we begin this lesson, it's important that you make sure that you have the materials you need to execute the chemical reaction that is going to occur. Though we are not going to use the word chemical reaction. You are going to use two mystery matters. Alright, mystery matter 1 will be baking soda, and mystery matter number 2 will be vinegar. During this chemical reaction, it will be important that you demonstrate proper safety procedures by wearing eye protection. So you should also distribute the safety goggles that are with your kit as well. To prepare this chemical reaction, you will pour some of the baking soda. You'll actually pour it to the 50 milliliter line that you'll be able to see on the graduated cylinder. That should be more than enough. And then you are going to add roughly 2 or 3 scoops of the mystery white powder or the baking soda. And to do that most effectively into the balloon, you are going to want to use the funnel that comes. Now, before you actually create the mixture and the chemical reaction, you're going to bring your students together and explain to them what you are going to do. Right? Tell them that you are going to mix two materials together, two mystery matters. All right? The liquid, or what they might identify as a liquid, and this powdery substance, which is a solid. And you are going to explain before you do so that you're going to pull this balloon over the top, right? And in a moment you will tip the balloon up, right, so that the powder enters the mystery liquid. Before you do that, ask students to collect some data, either by taking a photo with their device or by drawing a sketch of this setup, this system, in their student notebook. Right? Once students have collected that information, that before moment, right, you're going to once again bring them together and say we're now going to mix the two the two matters together, and we're going to observe what happens. Right? Again, eye protection should be worn during this experiment because you never know what might happen with this balloon. So, we're going to dump that in, and we are going to watch and observe. Okay? Now, students will immediately notice this bubbling effect. They are going to, of course, see that the balloon is inflating. Right? Your job as a teacher right now is to draw out those observations. When kids share what they think is happening, you say, hold on, make sure you can support what you're sharing. What is it that we are observing? Because students are going to be collecting those observations, collecting those data points to use later to construct their explanations about what is going on inside this balloon and what we call an Erlenmeyer flask. Though you can just call it a bottle, of course. Now, something that you might do once the reaction appears to be completed, you might give it a little swish around. That might create a little more activity. Make sure students do have an opportunity to take turns to really look in close at what exactly is going on. They should see bubbles being generated in that liquid. That is important for their explanations for later. And then what you might even want to do is that you might want to actually demonstrate for your kids that this is now sort of what we call a closed system. It's something where things are not escaping. And so you might actually pour down into the balloon and then allow it to pour back out. This might also be important because we're going to ask students in later lessons to explain what is going on with the matter inside here in the balloon. It can often, misconception is often that some of this liquid sort of gets up and stays in there. Right, so by sort of tipping it all in and then tipping it out and realizing that that balloon is in fact going to keep its shape is something that students may use as a data point later in explanations. Along with the students recording their observations, they're also going to want to take a photo or draw a diagram of the after mixture experience. So again, they're going to collect and put that in their student notebook for reference later. At the conclusion of the demonstration, your students should likely have something that looks a little bit like this on their mystery matter mixture observations page. Right? You should have a before and after image and at least 2 or 3 observations that they will have pair shared and group shared in the classroom together. On the next page, you should give students independent time to record their current explanation for what happened when we mixed the 2 mystery matters together. Now, one thing that you might encourage students to include is a picture or diagram that may be used to help explain visually what they've written here. Now, this is very early in the 5th grade year where modeling is being done, but you might be able to encourage this idea of thinking about things that are happening in really small or really large scales by encouraging kids to include in their model what they think is going on with the matter in that really, in that space where the 2 matters interacted, right? What do they think is happening to the liquid and the solid, right? You might even ask them to think a little bit about sharing what do they think is going on here in the balloon that would cause the balloon to inflate, right? These are 2 particularly good prompts that you can ask students who maybe record their explanations quickly or are stuck and don't really know what to write about. And it will also give you a really good sense of current student conceptions or misconceptions around what is happening with gas, liquid, and solid matter and the mixing and combination or creation of a new matter during that chemical reaction. Again, what's important in this lesson is to get the students' ideas, their initial explanations, and not giving them the right answer, so to speak. We'll let them discover that as we move through the remaining lessons in our unit. In conclusion, this lesson asks students to make observations to produce data that will serve as the basis for evidence of their explanation of what's going on with the mystery mixture. As a teacher, it's your opportunity to understand students' current conceptions or misconceptions around matter and chemical reactions. As teachers, we also get a chance to assess the understanding of students' sense of scale, particularly using a scale at which is not observable to the human eye.